Hello everyone, welcome to Illustraca. So this is the first lesson of this video lecture series on SAP2000. In this whole series, I'll be showing you from a basic to advanced options present in SAP2000 and how we can use those for your daily works. So let's get started. So here I'm using the latest version of SAP2000 and you can see it is the version 24. You can use any older versions also. Few changes are there, few enhancements are there in the updated software, but you will find it pretty similar with the older versions also. So here, to begin a new structure, or you can say to begin a new model, what you have to do, you have to click on this file as every other software, and then you have to click on this new model. So I'll click on new model here. Now it will give a pop-up window to create the grids. So let's wait for it. Yes. So now you can see there is a pop-up window, and here you can select the units on which you want to work. So I'll be working on kilonewton meter, or you can also make it kilonewton mm. So let's click on this kilonewton meter and centigrade. You can also save these settings as your default settings. So whenever the next time you open these the software, it will be having the same settings, so you do not have to choose again and again. Default materials. So the default materials will be having the Indian materials. That means the grade of concrete and steel as per Indian standards. Now, to create a blank, you can say workspace, you can click on blank. To create the grids, you can click on this grid only. And different setups, you can say templates are available here for beam, for 2D truss, 3D truss, okay, for 2D frames. So these templates also you can use. So for now, I'll click on this grid only. So I'll be creating some grids so that we can, you can say, use those grids for creating our geometry. So I'll click on this grid only. Now it will give you this quick grid line option. Now in this quick grid line, you can only put the data to create a, you can say, a grid of uniform spacing in either direction. So let's not you can say bother about this, because we are going to change it later. So for now, let me create 4 number of grids in X direction and 4 number of grids in Y direction, and maybe 4 number of grids in Z direction, that means my vertical direction. Okay, and the grid spacing in X direction, maybe I'll make it 5 meter. Grid spacing in Y direction also 5 meter, and in vertical direction I'll be keeping it as 3 meter. The initial point will be 0, 0, 0. So I'll click on OK now. So here you can see we have created the grids in all the 3 dimensions, X, Y, and Z. Okay. So now if you want to change these grids, you can always do this from here also. Okay, don't have to worry about it. Now let's get familiar with the software interface. It is pretty like the ETABS software. Those who have used ETABS, so you can easily use this SAP2000 also, but there are many advanced options available in SAP2000. And the modeling approach is also different, because it is not only for buildings, it is for any type of software, you can say structure, you can model it and you can analyze and design it here. So here in this left side, you will find some selection and draw tools. Okay, so these tools are also available here in draw, you can see, and also in select, like the previous selection and now. And here it is very given in a hierarchy. So first we'll be you can say defining the materials, the section properties and all. Then we'll be drawing the objects, or you can say drawing the structural elements. Then if we require to select anything, we can select from here. If you want to assign, if you can say if you want to impose something like any property or any load, so it will be from here. If you want to analyze the structure for the given loading, so you can analyze from here, and different settings you can find here. If you want to display the results, the loads, you can display from here, and if you want to design, then it will be under design. And if you want to edit any geometry, you can get it from this edit menu. Okay, and these are the shortcuts available also here, like save, open, run analysis, lock model. Okay, zoom in, zoom out. Then we have pan, 3D view. Then we have this plan view and elevation views. Okay, and then using these arrows you can go up and down in this plan view. Like you can see, it is now z equal to 9, so we are at the top floor. You can see the work plane here in blue color. So if I just go down, you can see the work plane is changing in the 3D. Okay, so this is the use of these arrows. And then you have these shortcuts for designing and you can say displaying the result. So these are also available here. If you see display, so you can see these options are also available here. Okay, fine. So now let us model a very small, you can say pretty simple, you can say building structure. Then I will show you other different type of things. So before jumping into building structure, what I will show you that here in SAP 2000 you can use your points, you can say lines to create different type of geometry. Suppose I'll be creating a point here, so I'll just click on this draw, and here you will find this draw point. So you can click on this draw special joint. Okay, so I'll click on this draw special joint, and I'll click on here. Okay, so this joint is visible. Now I'll click on this select mode, so this joint is visible. And if you go to 3D view, you can see the joint is created at the bottom of the structure. Now suppose I want to create a column here. Using this joint I can create a column. How? Let us select this joint, and before that let me define some material and sections. So let the point be here, and I'll go to define material properties. Here some Indian I can say standard materials are defined for steel, structural steel and concrete. So I'll again define few I can say material properties. So I'll click on this add new material. I'll select from here India concrete, and I'll select maybe M25 grade. Okay, then I'll click on this add new material. I'll change it to rebar. Maybe I will define this HOSD 415 and also HOSD 500. Okay, and I'll click on OK. Now what I will do, I'll go to define and section properties, and I'll define some sections also. So I'll go to frame sections. I'll click on this add new property, and I want to create some I can say concrete section. So I'll click on this concrete here, and maybe rectangular section. So here now it is showing us the column section, right? So let me just write it here as C1, and maybe I'll create a column of 400 by 400. So it is, you can write it as 400 by 400. So here it is in meters, so I'll put it in 0.4 and 0.4. Okay, so you have changed the dimensions. Now you can select the material property from here. I'll select M25 grade. Now if you want to change the reinforcement distribution in this column, now it is equal in 4 sides, right? So if you want to change the reinforcement distribution in columns, you can always click on this concrete reinforcement, and you can change from here. So you can see now the design type is column. Longitudinal bars, for longitudinal bars I'll select the grade of HOSD 500, and for confinement bars, that means for stirrups, I'll select it as HOSD 415 as mentioned in code. So then I'll click on the design type as column. If you select this design type as column, then only this reinforcement distribution will be coming here, and you can choose the distribution how you want to provide. So here both sides, so I'm providing 3 bars, so let it be here for now. The cover I'm using 40 mm cover. Don't worry about the bar sizes, it doesn't matter actually, only the distribution is going to give you the you can say PMM interaction. So once you provide the distribution, then automatically the software will take from smaller to higher size of bars, and it will create the interaction curve. Okay, so for now, if you want, you can change it from here. Actually, the design code I think selected as a different code, so that's why the bar sizes are coming like this. So that we will see later. Don't worry about it. And obviously if you want to design a structure, means design the column, so you'll be checking here reinforcement to be designed. And if you want to check the, you can say, capacity of the column providing the reinforcement, then you can click on this reinforcement to be checked. But for now I'll click on this the default one, reinforcement to be designed, and I'll click on OK. Okay, so the column is defined here, and click on OK. And let us define a beam section. So what I will do, I'll make a copy of this property, and I'll change this from beam column to beam. These will be same, and maybe the, now here it is not clear cover, it is the effective cover, so I'll be giving the effective cover as 41. Okay, so I'll click on OK. Now you can see it is a beam, and I'll create a beam of 200 by 400. Okay, so I'll change the name as B1 200 by 400. Okay, I'll click on OK and click on OK here. Okay, let me create a slab definition also. So I'll go to define, and here we have section properties and area sections. Now here you will not find the slab sections as it is available in ETABS. Okay, so it is area sections. That means you can create walls, you can create slabs, or different type of like foundations you can create using this. So I'll click on this area section. So the type of section will be shell. I'll click on add new section. Now here obviously as we are creating shell, I can say slabs, so you can select this either shell thin or membrane. So whenever you want to create, I can say select to see the exact behavior of slab, so you need to select the shell thin. Otherwise if you're just using the slab for as a load transfer mechanism, so you can select the membrane also. It is recommended to select shell thin. So now I will select shell thin here. I'll change the slab, so it will be suppose as 125. Okay, so I'll change the thickness, so it will be 0.125 and 0.125. So here two properties are given actually, bending and membrane, so load transfer and to show you the bending behavior. Okay, so both will be keeping the same thickness. Material property I'll select M25, fine. And design parameters we do not require now. Okay, we will see it later if required, and I'll click on OK here. See, now SAP2000 is mostly used for analysis. Whenever we you can say analyze any critical structure, so you can easily analyze the structure in SAP2000, and you can use your you can say own tools like Excel sheets and all for designing the members, getting those you can say results from the software itself. And if you want to design it here itself in the software, it is also possible. Okay, so S25 means 125 mm thickness we have considered. Let me take a wall property, so I'll make a copy of this section, and maybe a wall of 200 mm thickness. So it will be the shell thin only, so I'll make it 2 and 2. Okay, so 200 mm thickness, same grade. Design parameters will not change it now, we'll see it later, and I'll click on OK. So we have created two area properties, one is for the slab, one is for the wall. I'll click on OK. Now let me show you a few things here. So we have created a joint here, or you can say a point here. Using this point you can create the columns actually. Okay, so how it is possible? So let me just select this point, and if I go to edit, extrude here, and here you will find this option, extrude points to frames and cables. So this point can be extruded to frame also. So I'll just select this one. How it will be? It will be a linear, I can say extrusion. So I'll select this linear. I'll select the property, so it will be column 400 by 400. Now which direction? Obviously it is in Z direction and upward, so I'll make it a positive value of 3. And how many stories you want to create? Suppose 1 story, so I'll just make it as 1. And if you just click on OK, you can see it will create a frame here. And if you see the section, so if you just click on this set display option, and in general options, if you just view type as extrude, you can see we have created that 400 by 400 column here. Okay. Similarly, you can create for all stories. So for that, what I will do, I will just undo this. Okay, I'll go to the XY plane. So we are in Z equal to 0. I'll go to draw special joints, and I'll draw joints here like this for all the grid points. I don't know whether it will be created or not. Let me see if there is any quick draw option. No, okay, so I need to click like this. Yes, so you can see we have created the points here. Now I'll close it. So let me go to the 3D view. You can see the points are created. Now if I go to XY plane and I select all these joints, if you go to 3D view, you can see all the joints are selected. You can go to edit, extrude points to frames and cables. So I'll select this. Similarly, column property 3 meter and 1 number. So I'll click on OK. So you can see all these columns are created now, right? So let me just turn off the solid extruded view. Now similarly, you can create the beams also using the extrusion in this direction and the other direction, but we will not do that. We will go to this level, which is my 3 meter level, and here we have this quick draw frame option. So I'll just click on this. Property will be my beam B1, and I'll just drag like this. You can see the beam is created. If you go to 3D view, you can see the beams are also created, right? Similarly, you can draw the slabs also. So if you click on, suppose here, quick draw area, you select the area slab 125 and you drag like this. So the slabs will be created. Now you can see the slabs are not visible, like the shaded area is not visible. It's just a boundary it is showing, right? If you see the 3D view also, it is showing just the boundary also. So for that, you just have to go to here, set display options. You go to general options and you have to click here fill objects. So I'll click on fill object and OK. Now it will show you the slab. You can see the slab is drawn here. Now, as we have seen that we can extrude the joints to frame objects, we can also extrude the frame objects or lines to area elements. Okay, so or you can say shell elements. So what I can do, I can select these two, suppose these two line elements or beams, and I'll go to edit and here extrude. Here you will find this option, extrude lines to areas. So I'll click on this extrude line to areas, and suppose I want to change these lines to a wall. So I'll select the wall property, wall 200, and it will be downward direction, right? 3 meters. So I'll make it as -3, number 1. And you check this option, delete source object, if you want to delete these beams, or if you want to keep these beams, you just uncheck this. So I do not want to keep this beam here because I'll be putting the wall here. So I'll check this and I'll click on OK. You can see how easily we have created the walls. Now let us see how we can mesh these walls in slabs. So for walls, I'll use the, I can say, edit option, or you can say manual option. So I'll just click on this walls here. Okay, and I'll go to edit. Here you will find this edit areas and divide areas. So here you will find this option, divide areas into different number of segments. Okay, different number of segments. So you can use this option, divide area into objects, as you can also use this one, like of what maximum size you want to divide it. So suppose I want to use this option and I do not want to divide these walls in both the directions along edge 1 to 2. So that means this one is 1 to 2. So I'll make it 5 and I'll make it 1, and I'll click on, I'll select the objects. It is sometimes it is confusing because in ETABS we can divide it using by checking the local axis, but here it is some points, so you just have to can say check it once. Now I'll click on apply. So this is the way we want to mesh. Okay, and for these slabs, what I will do, I will just go to select properties, and you can say we have the area sections, S125, select. Now here I want to use this option, divide area into objects of this maximum size. So as I have divided the walls into 1 meter strips, so maybe I want the slabs also having maximum 1 meter size, but these slabs may divide into quads or triangles. Means maybe a triangular shape or quadrilateral shape will be created where it is required, otherwise rectangular shape also be there. Okay, so this is the maximum size that we have kept, 1 meter. Okay, now click on apply. So there is no requirement of dividing it using these options. Actually you can directly use these options. You can see how it is divided automatically. Okay, so you have done the, you can say, meshing. Right, now if I go to XY plane and if I go down, so this is my points, and what I will do, I'll select these points, I'll go to assign joints and restraints, and I'll make it fixed. Okay, so if you go to 3D view, you can see we have created the floor with columns and walls. So you can again see the extruded view from here, general options, extrude. Okay, so you can see the extruded option, right? So it is pretty easy actually. These columns also will not require because we have the wall here. So if you want, you can remove these columns. Okay, so let me go to XY plane. Let me select like this and delete. So let me see if these columns are deleted. Yes, no, these columns are not deleted. Let me change the extruded view to standard. Okay, and let me select it like this and delete it. Yes. Okay, so now you can see we have created the structure. So easily, if you want to analyze, you can analyze from here. If you just click on this analyze, now we have not applied any load, just it will be analyzed for its self weight. So I'll click on this run analysis. Here you can see the self weight and the model. Model you do not want, so let me click on this do not run, and I'll click on, like it is saying asking analysis monitor options show after 4 seconds. That means there will be a I can say text file which will be showing you what are the analysis it is doing in the background. So if you want, you can keep it alive. Then I'll click on this run now. Let me save it. So here you can see we are seeing the analysis model here. Okay, so there are now different options. You can see the stresses, you can see the bending moments. So from here you can see the show forces and stresses. For frames you can see the moment 3 measure moment. You can see how it is. You can turn off the fill for the wall and slab, and you can see these bending moments. If you want to see the values, I think it is possible. Show values, apply. You can see it will show you the values also here. Okay, shear force diagram. You can see shear force diagram also for the frames. If you want to see the torsion, you can see as it is the end you can say beam. So in this we have this end moments, sorry, the torsions in the beams, because here to balance the load in the other side we do not have anything, right? So that's why we are getting this torsion, considering the joint between slab and beam as rigid. Okay, if you want to see the axial force, you can see the axial force also in the columns. Okay, so this is the way you can create some model here. Now let me show you what are the different things you can also create. Let me save it and let me create a new model, and let me take grid only. Now here, rather creating the linear grids, what I can do, we can also create the cylindrical grids. Okay, so now here if you see, these are the options you need to actually take care of. So here it is saying along radius, number of grids along radius. So suppose this is my center point and this is my radius. Okay, now along these radius, how many number of grids you want? Okay, so this is what along radius, number of grids. So suppose a number of grids along radius we want 3. Okay, along theta means this one, this is theta. So along theta how many? So to complete 360 degree, how many divisions you want? So suppose we want 36 divisions of 10 degree each. Okay, this theta equal to 10 degree. Okay, so I will just select along theta, it will be 36. Along z, suppose you want to create a you can say a circular tank, so it will be something like this. Now along z, how many divisions you want? Okay, so suppose along z I want 10 divisions. Okay, 10 divisions in 3 meter, 10 divisions. Okay, so now here along radius, what is the spacing? So again, this spacing is nothing but the spacing between each so this is my circle, this is the radius, and these are my grids. Okay, so spacing means spacing of this each grid. So suppose each grid I want of 3 or maybe 1 meter. So 1 1 1 3 meter we will be having. Okay, so I'll select it as each grid of 3 meter along theta. So as we have 36, so it will be 10, then only we can complete the 60 degree. And along z, it will be, as we have 10 number of divisions, grid lines. So if I just make it 3000 is my total 10 number of grids, so it will be 300. So what I will do, I'll make it 0.3. Okay, let me check whether it is working or not. So I'll just click on OK, and I think yes, it is correct. So 10 number of divisions for 3 meter height it has created. Now easily you can create the, you can say, tank here if required. Like the circle, the inner circle may be not required, but depends on how you are doing actually. So easily you can do. I think the materials are already defined. Let me check. Okay, let me define a shell section, maybe wall 200 again, and I'll make it 200 and make it 200 here, maybe M30. Okay, fine. So now what you can do, you can draw walls here around this. So for this, suppose I want to draw one beam here, just any beam draw here, or from here to here. Then I'll close it. Then I'll select this beam. I'll go to edit. I'll go to replicate, and here I'll go to radial. So now this plane is parallel to Z, right? Means the I can say rotation will be parallel to Z. So I'll select this parallel to Z, and the point about which the rotation will be happening. So this is the point I can select from here. pick point on model. So you can see, I think it has selected the point, and number of segments, it will be 36, and the angle between each segment will be 10 degree. Now if I click on apply and OK, you can see the lines are created here. Now easily you can select these lines like this. You can go to edit, extrude lines to areas. You can select the wall property and give in Z direction as -3. Okay, -3, or maybe you can provide, okay, -3. Let us provide -3 only, and number will be 1, and click on delete source object and OK. So you can see we have created the walls. Here if I go to set display options, general options, and fill object, general options, make sure you click on this so that the thing will be applied to all the windows. So apply. You can see how easily we have created the walls, and you can divide it also as per your grid, I guess. So I'll select like this. I'll go to edit areas, divide areas. So let us select this option. Let me see where it is there. Yes, divide area based on points and area edges, quads and triangles only, intersections of visible straight grid lines with area edges. Okay, maybe you can select all the things, but for us nothing is available. No, I can say line object is available, so doesn't matter. So we need this first one only, and click on apply. So you can see here now, as per my grid, these walls are divided. Okay, so this is how you can create a different type of objects, different type of models. You can create silos, you can create overhead tanks, underground tanks, you can create foundation models. So everything it is possible in SAP 2000. So this is the introductory session I wanted to give actually. We'll be seeing more such things in SAP 2000, like a different type of loadings, non-uniform loadings. In SAP 2000, this non-uniform loading become a very easier process now. So I will show that also in the coming videos. So I'll stop this video here only. I hope you will be liking this video or this series. So if you have any doubt, you can always you can say put it in the comment box, and if you have any suggestion, you can always, it is always welcome. You please write in the comment box. I'll try to you can say implement that in my videos. So thank you, and we will see you in the next video.